inverse is 1/2 x plus 3/2. What's the derivative of that? I'm going to write it a little differently because with the f inverse there, it's a little different. So the derivative of f inverse is 1/2. How are those two derivatives related? The reciprocals, right? Everyone agree? So they are
the inverse. You could have actually just taken the beginning one and just flipped it.
to find a derivative of the inverse. Yeah, maybe. So it says graph f of x, f inverse, and y equals x. So f of x, what was the y-axis? 3? 2x plus 3. Right, so run 1. Questions? Okay. And then 2x. There's 1/2 x plus 3/2. So 3/2, which is 1.5. Rise 1, run 2. And then it says to graph the line y equals x, which is that little line right there. I'm going to extend my blue line a little farther. What do you notice about these 3 lines? Well, if you remember from Algebra 2, the 2 inverse functions are reflections of the line y equals x. But what I want to talk a little bit about is that whole slope thing that we just figured out, the reciprocal thing. We agree, we think the derivatives of 2 inverse functions are reciprocals. Would that make sense? Slope is y over x. So if I switch x and y, wouldn't it flip the slope? The weird thing about it, though, this is a line. So the slope along the line is the same all the way across. But the weird thing about the inverse derivative thing is if the slope were changing, what is the corresponding point to this one on this graph? Where are the x's and y's the same but switched? It's this point, right? So the slopes are reciprocals, but they are reciprocals at different x values. They are reciprocals at 0. This slope is the reciprocal of that slope when y is 0. So that will create a small challenge, and that's what we're going to learn about today. Okay, so I'm going to go through the proof of the inverse derivative. If f and g are inverse functions, then f of g of x equals x. You learned that in Algebra 2 at some point. So I'm going to look at this derivative implicitly just for a moment. We're going to look at what the derivative of the inverse looks like. Can I take this derivative? What is the derivative of f of g of x? You know that now from f g of x prime dx. And Norm, on your calculus helper, it does say times u prime. Why do I not have to have a u prime out here on this one? It's just x, the derivative of x is 1, so I can write 1 there out there if I want to. If I want to know, so f and g are inverse functions, if I want to know the derivative of g in terms of f, I'm going to find that. The derivative of g, would you agree, would be 1 over f prime of g of x. Yeah, well, what does that mean, right? Well, let's talk about how g and f are related. If I put in an x value into g, doesn't that give me a y value on f? Or it actually gives me an x value on f? It's switches the x and y, right? So this is really a y value. This is a weird way to write it. But if I want g prime of x, I really want 1 over f prime of the y value at that corresponding x. Because the g of x is the y value. So if I want to find g prime of x, I can use its inverse function in its derivative, and it's 1 over the derivative, but it's at the y value, not the x value. We will use this formula. I'm also going to show you another option other than the formula, which is a table. Trick. So, key things to remember about f inverse and the derivative of f inverse. To find f inverse, if you are ever asked to do that, you switch x and y off y. The slopes of f of x and f inverse are reciprocals. But don't forget that every x and y is switched. So those reciprocals do happen at a different x value. I did not see this chart until when I was in high school. I always just used the formula. I saw this chart at an AP conference a long time ago, and students really like it. The one problem with the chart is students forget. If you are a note card keeper, like you did note cards in your pre-cal or your Algebra 2 class, and you still refer back to this, if you like the table, it might be something you want to put on a note card because it is something that people forget how to do a lot. So I'm going to show you both the formula option and the table option. The table option organizes x, y, and m, kind of lets you see the flipping of your x and y for the inverse. So I have an example here. It says if f of 2 is 7 and f prime of 2 is 8, then what is f inverse of 7? And what is the derivative of f inverse of 7? First of all, let's answer the f inverse of 7 question. Does anyone know what f inverse of 7 is? No derivatives. No derivatives. If f of 2 is 7, 2. Why is it 2? The inverse switches the x and y. So if f of 2 is 7, then f inverse of 2 of 7 is 2. So I'm going to put that down on a table. So f of 2 is 7. So that means f inverse of 7 is 2 because I'm going to switch this to y. So that's what the inverse does. Do you remember this? Do you like the table? I remember it, but I don't remember which way you like better. Do either of you remember? Did you like the table?
I could never figure out when to use it.
When you're finding the derivative of an inverse.
And I couldn't figure out how to organize it.
So you might like a formula better, which I'll show you that one. What is the slope of f of x at 2? What is the slope of f inverse? Okay. But what I do want you to notice is where is that the slope on f inverse? At 7. F inverse derivative at 7 is an 8. Now luckily this question didn't give you any options to mess that up because they didn't ask you the inverse at 2, so you couldn't really mess that up. But you can see how that could get a little tricky. I do want to show you the formula as well. F inverse's derivative is 1 over f prime at the y value, right? to use the formula. That's how the table works. They both work great, and on this homework you'll think it's really easy. But as you heard Alexis and Katie say, this is something that students just for some reason have a really hard time keeping in their brain. And so it's something I star in my notes or write down, like this is something that I'm going to have a hard time remembering later. It's not that hard to do if you use one of these two options. Like I said, tonight's homework will be pretty easy, but the long-term gain of this is a tough one. I have a hard time keeping it. So let's do a couple more examples. If f of x and f inverse of x are both differentiable functions, with f of 3 equaling 5 and f prime of 3 equaling 7, what is one possible equation for the tangent line to f inverse at 5? So I want a tangent line of f inverse, which means I need an x, y, and m. This table is really nice for x, y, and m for a tangent line because it kind of all lays it out there for you. So the first thing I'm going to look at is the x and y on f. And so what is the x and y that I'm given on f of x? 3 and 5. Which means what is the x and y that I am relating that to on f inverse? Because the x's and y's are switched, right? What is the slope? 7. So what is the slope of the inverse? You see how the table's really nice to organize those thoughts. If you can remember to use the table, it's really a nice option.
I thought anytime you get the inverse of the slope, it becomes negative.
No, it's just reciprocal because the x's and y's switch. So rise over run becomes run over rise. The negative is when you do a perpendicular line. So a normal line, you flip it and make it negative. From a tangent line to a normal line, that's what we do. For an inverse function, you just flip. So the tangent line would be y minus 3 equals 1 7 times x plus. Here's where this gets a little tricky. Because now I have a lot of values on the table. This asks me to find g prime of 2, and it tells me g is the inverse of that, and it asks me to find g prime of 2. See if you can do that. This table is not the other table. So if you want the other table, you will have to draw the other. I wanting to find the derivative of g at? Does everyone agree I want the derivative of g at 2? What does that mean on F? That'll be the Y value on F. So when does F have a Y value of 2? At -3. Everyone's check. So this is the column I'm looking at. This was a distractor. Was it a very good distractor? Yes, because how many people do you think put 1/4 as the answer to this? Right? It's tempting, right? Remember, you need the Y value. You need the one for the derivative at the Y value. So this is 5. That's the fifth. With the table, it's a pretty easy question. Without the table, it's tricky. So again, I really like the table. I normally don't like tricks because they're hard to remember. But this is a trick. I feel like it's worth remembering. You know, worth putting down and putting in your brain. If you were doing it with the formula, you would do 1 over f prime of the y value, right? And so f prime at the y value, which is -3, is where you get the 5, and you get 1/5 either way. I kind of like the table set up. I will do this proof tomorrow. You can see your calculus helper for those inverse trig derivative rules. For now, you can just follow them. We'll also do PDF log. I'll show you why. Both of those tomorrow. Both of these homeworks are due on Monday. So the worksheet with the book page, as you can see, it's written on the worksheet. This book page is not written on the worksheet. It's using derivatives of exponentials and logarithms. You've actually, both that book page and this book page, you've done problems like that already on your gateway. So tomorrow I'm just going to talk to you about why those derivatives are what they are. If you wanted to work ahead, you could do the derivatives because you had a calculus helper. You know what I mean by that? So it's up to you how you do that. These are both due on Monday. One piece of information you will need for the homework is that velocity is the derivative of the position constant. So you'll need that piece of information. Velocity is the derivative of